tranquil and artificial paradise. Paradise, 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 paradise.
Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or watching the recording, I appreciate you watching. As we get started today, just a brief, quick announcement. This is a reminder that the study hall time, that's Thursdays from 10:30 a.m. to 3:30 p.m. in Paxoi Room 3200. That is canceled this week. That's what I sent out the announcement yesterday about. No study hall this week because I will be gone to a cybersecurity conference. So I won't be here to answer your questions in person at the study hall. I will be out of town. Also, just a moment, please. Sorry about that, everybody. Got a phone call right there at the start of class that I had to take really quickly that I needed to just go ahead and square away. We'll try to trim that out of the recording there. Let's see, where were we? We were saying that I've completely lost my train of thought. I'm sorry. No study hall this week. No study hall on Thursday. I'll be out of town. Won't be here to do it. But we'll be back to regular schedule next week. This week we're talking about programmatic thinking, and actually I think the lab assignment in this module is one that a lot of people have a lot of fun with. So I hope you all enjoy that one. It kind of holds your hand and walks you through some basic block model programming, which we'll do some examples of toward the end of our live stream time today. But in the next module, Module 4, we talk about Python programming. We start to do a little bit of programming ourselves. And as we are looking at that, one of the things that we're really looking at here is how we think like a programmer. Because thinking like a programmer is really different. Right? You might not think that thinking like a programmer would be different than thinking like anyone else, but thinking like a programmer is actually kind of different. So I think we want to take some time to talk about kind of how we think like a programmer, and then we'll show off some of our block logic. And the big point of looking at our block logic a little bit later is that we're going to relate that to, that's going to give us a visual for how code works, so that when we get into our coding module in the next module, it will give us the opportunity to kind of already understand the basics behind what it's doing. But really, programming requires a very special way of thinking. Right? One of the big things that you really need to be a good programmer is you have to kind of like solving problems. Because in the real world, nobody's going to hand you a solved problem. One of the things that we talk about, kind of the idea behind the discussion for this module, is the concept behind algorithms. We'll talk about what an algorithm is in just a little bit. But really, when we examine an algorithm is really nothing more than just solving a problem, or a problem that needs to be solved, and the steps that we take to solve that problem. So when we're approaching programming, one of the big things that really helps us out is if we like solving problems, if we like trying to find a solution that will allow us to fix something. And again, the key thing with that is a problem does not come to you solved. Another key thing to that is the fact that you can solve a problem in different ways. There's not just one way to solve a problem. So programming really requires a special way of thinking. And, really it's true for whenever we're learning something new, we have to have a new mindset. And programming is no different, right? We're approaching a new mindset to programming and a new mindset to, just as we'd approach a new mindset to anything that we learn. When you were learning division for the first time, right? Maybe back in, first or second grade, whenever people learn division nowadays. When you were learning how to divide numbers for the first time, you had to approach the problem of division in a different way than you had approached any other problem at that point. And then you started talking about, then from there, as you got more complicated, you started talking about division in relation to word problems and in relation to all this other stuff, right? And so, you had to open up your mind just a little bit more to accommodate different things to your idea of division and how division works, right? Because it's not just like number divided by number, but it's also, candy divided by children. How many pieces of candy can we give each child to give them an equal amount of candy for each child? That sort of thing. Right? And so these are problems that have to be solved, and we have to change our mindset to solve these new problems. And programming is really different from other things that you can learn, right? And this is a discussion that I have basically every semester. When you go into a networking class and they teach you how to configure a switch, right? There might be some different parameters that you could make a little bit different on that switch, but there's basically one way that you configure that switch. When you're looking at fixing a computer, there might be some different parts that you can put them in. You might, do some different diagnostics to test different things. But there's basically one way that you fix a computer. When you're writing a program, there's more than one way to write a program. There's more than one way to solve a particular problem. Right? And as we progress, one of the things you'll kind of see is, some ways of solving a program come easier, or some ways of solving a problem with programming come easier to me than other ways do. We'll talk about different logic control structures. We'll talk about things like conditionals and loops and things of that nature, and how they can allow us to do different things. So since there's more than one way to solve a problem, and you're never going to be presented with a solved problem, learning to program is more abstract than anything else you can learn. right? Like in a lot of university computer science courses, they don't even teach you how to program. They teach you a lot of the concepts surrounding programming and how a program works. But then the actual, data structures and algorithms and how to, and things like that. But when it comes to the actual mechanics of programming, they don't even bother teaching you that. You have to learn that on your own. Here we take a little bit of a different approach to that. We actually, go through the mechanics of, learning how to do that. But one of the things that I say as we do that is when we think about programming, we can almost think about a puzzle, a jigsaw puzzle, right? If you've ever done a jigsaw puzzle before, you get it in a box. Maybe there are 24 pieces, maybe there are 100 pieces, maybe there are 500 pieces, 1,000 pieces, 5,000 pieces, so on and so forth. Right? There's any myriad number of pieces to that puzzle. And if you take those pieces out and you put them all together in the right way, then you get the picture that's on the front of the box. Right? So when we're programming, and I think it really hammers it home when we look at the block logic, like we'll be looking at it in a little bit. When we're programming and we're learning the mechanics of programming, what I give you, what I can teach you easily, are the puzzle pieces. Right? I can easily teach you the puzzle pieces of how to do the mechanics to write a specific puzzle piece. What becomes way more difficult is taking these different puzzle pieces and making them look like the picture on the box in order to solve your problem. Because we're going to use the same puzzle pieces and just arrange them in different configurations to solve different problems. So that's really what, kind of makes this big challenging, is this idea that there are more than one way to solve a problem, and then we just kind of have a toolbox full of tools, and we want to make sure we're using the right tools that make sense to us to solve our problem. So let's examine some ways that we can kind of change our thinking as we approach this new challenge. The first thing we can do is write things down, right? And this is the kind of thing that they tell you when you start to write essays too, right? Do some pre-writing, do some planning, write some essays that are write some words on a piece of paper that aren't your essay. Just plan things out. And, when we're in high school and they tell us to, do some pre-writing for your essay, or, plan out your essay, a lot of times we just think, I'm not going to do that. That's busy work. I'm not going to pre-plan my essay. I'm just going to start writing. I'm going to wing it. And maybe you do that a few times, and maybe you get away with it the entire time you're in high school and writing essays. But maybe there's a time or two that you don't. Maybe there's a time or two when you're writing your essay that you realize, it would have been a lot more easy. I'd have had this done a lot faster had I have sat down and made a plan for the things that I needed to write about, for the things that I needed to talk about, in order to answer the question that was posed to me before I actually sat down and started writing. That way I don't miss anything. That way I make sure everything's covered and I'm doing everything properly. So when we're writing code, we really want to do the same thing. Coding starts with a pencil. It's a lot easier to kind of sit down and make mistakes and try to figure things out when we have a pencil and a piece of paper in front of us than it would be otherwise if we were trying to, just jump into writing code. We can sit down and we can wrap our heads around a problem and we can gain an understanding of what we're doing. And then from there, once we have an understanding of, okay, this is the problem that I'm solving. These are all the steps that I need to take to be able to solve this problem. This is the order I need to execute these steps in order to properly solve the problem. Then I could start writing code. And I could just go through my list and check things off and make sure they work the way that I expect them to as I go through. Right? That's going to make life a whole lot easier. That's going to make things a whole lot simpler. So, we might think that, oh yeah, that's busy work. That's not a big deal. It's not a big deal. That's busy work. But it is. It's a huge deal. Right? Just a few extra minutes up front. Just sitting down and writing things out. Just taking that time you need to write out everything you need to do. For, 10, 20, 30 minutes. Before you actually start to write code. Can save you hours. Days even. On the back end after you're actually writing code. Right, because the last thing you'd want to do is work for days on a program in order to solve a problem and then realize, oh no, I left out a step. I'm supposed to be doing something else here that I'm not doing. So now not only do I have to go back and fix it and add that thing, but all the other parts of my program are already working together and doing things on their own. So I have to make it fit in the existing structure. So it's going to take me even longer to fix than it would have to write it initially had I approached the problem that way to begin with. So, taking a little extra time and writing things down first is going to save us hours, maybe even days later on as we're trying to figure things out. Another thing is that programming requires precision. If we were in a room together, this would be, right before I put this slide on the screen, I would ask you if you thought your computer was smart. Sometimes people say yes, sometimes people say no. The realization is that we are smart. People are smart. Computers are not smart. Right? And that's one of the reasons why we talk about the history of computers. We can see, exactly how simple computers are, how the history of programming kind of works. And we can see and we can see that precision, or that computers are really, not that smart, right? They just operate on a series of ones and zeros on that binary system that we were talking about back when we were talking about the history of computers. And so it's just a sequence of electrical impulses that we tell it to do that allows it to do things. And so as a result, if we go back to that idea of binary, we can look at our ASCII table again, like we were doing previously. Right, you guys remember this thing from before? This one actually has the binary digits on it, which is a good one. Well, we can see here that a lowercase a is a decimal 97, or a binary 011000001, and an uppercase a is a 010000001, or a 65 in decimal. Right, so if we were to look at this from the perspective of ourselves, and we were to look at this word, I really need to turn down the sensitivity on this mouse, and this word, we as human beings, since we are smart, we can look at these two words and say, okay, first word's apple, second word's apple, they're both apple. Right? That's easy for me to understand. Easy peasy. I know that. I'm smart. I'm a human being. My computer looks at these two different words, and it sees two completely different things. Right? Because it's not seeing these words. It's not seeing the word apple and then this word apple. Our computer doesn't know what an apple is. We might be able to train our computer to kind of know what an apple looks like, so it can relate a series of ones and zeros in pixels to a series of ones and zeros in text through some kind of machine learning algorithm. But the word apple means absolutely nothing to my computer. It's just a sequence of binary characters. 0, 1, 1, 0, 1, 0, 0, 0, 0, 1, 0, whatever. Right? So this and this are two different things. So we want to make sure that when we're writing our code, we're writing things consistently. If we refer to something as lowercase a apple, we have to refer to it using the exact same uppercase and lowercase characters as we progress through. Otherwise, our computer's going to see something different. It's not going to be what we were calling it before, and it's not going to work. And just the difference between an uppercase letter and a lowercase letter, or the difference between a colon being there, or a comma being there, or some punctuation mark being there and not being there, can make the difference between your program working and your program failing. So programming requires precision. We have to be precise, and we have to make sure that we're being deliberate and not careless with the things that we type in. Because not only can one careless mistake that we're not quite paying full attention to break our program and cause it not to work, it can also make it hard to fix. Right? Because if you can imagine, programs are not just a few lines of code, right? Sometimes there are hundreds or even thousands of lines of code. And if you put one semicolon in the wrong spot, or you made one letter uppercase where it should have been lowercase, or vice versa, then it will break that entire program and cause it to fail and cause it not to work. And in certain applications, right, that doesn't really mean a whole lot. If the program's not important, that doesn't really mean much. But what if the program ran your banking app? Or what if that program ran your school email? Or what if that program ran like the database that stores your hospital records? Right? Precision in programming and making sure that we are not being careless with what we type, but that we are being careful about what we type and make sure that everything is consistent and accurate is important. 9 times out of 10, right, as you're getting started, 9 times out of 10, if you have an error, for those of you that are getting started, it's some kind of typo. It's some kind of thing where you left out a letter, where you made a letter uppercase where it should have been lowercase, where you misspelled a word. Right? Remember that my computer is not looking for a specific word. It's looking for a series of zeros and ones to be in a certain sequence. That's huge, right? That's enormous. And so a lot of that, again, just so we can have it kind of committed to the record here, falls back to ASCII. Right? And we looked at our ASCII table. And this, I think, is the ASCII table that we looked at previously. It shows us that we have different values for all the characters. Right? Even something like this right here, the difference between null and space. The difference between null and space. Null is nothing, and space is a space. Visually to us, they look exactly the same in their character form. completely different. And that can cause problems. Now, the next thing that I'm going to tell you to do is going to be one of the most difficult things that I could tell you to ever do. And that's to be comfortable with not knowing. This is the most challenging thing that we can do. And when I say this is the most challenging thing we can do, I'm not talking about programming there. I'm talking about getting comfortable with not knowing. Because as human beings, it's our human nature to want to know something. Right? We want to be good at something right away. Right? Maybe you did it when you were a younger kid. Maybe you're still doing it now, right? Like if you go out for, maybe if you went out for, some kind of sporting team, like if you went out for the basketball team when you were in when you were in middle school, maybe when you were in like the 7th grade, and you went out for the basketball team. Or you tried a new sport for the first time, like maybe you tried tennis for the first time. Right, when I was probably around 6th or 7th grade, right, I tried tennis for the first time, went to a little tennis camp. And I wanted to be really good at tennis right away. But I wasn't. I was pretty bad at it. And I could have let that overwhelm me, right? And I could have let that overcome me, and I could have stopped playing tennis. And eventually I did, because, it wasn't, I didn't really enjoy it that much. But, or maybe it was from a lack of tennis partners, people to play with. But eventually, as I kept playing and I kept kind of getting through it, I got a little bit better, and I got a little bit better, and I got a little bit better. And I did tennis as one of my PEs in college, and I could really smoke a serve by the time I got to the end of that class. Hit a really hard serve. So we want to be good right away, and we can kind of get disappointed when we're not, and we can let this sort of defeatist attitude kind of get us over, kind of come over us and beat us, that kind of closed mindset to where if I can't understand this right away, it's not because it's new and I'm just trying to learn it for the first time. It's because I'm dumb and I'll never be able to do it. That's not true. Although it is true if you think that. Right? If you let it beat you and you let it overwhelm you and you let it pull you down, that thought there is accurate. That you will probably never be able to code, not because you don't have the capability to it, but because at the first sign of at the first sign of not knowing something, you gave up. You threw in the towel. You said it was too hard. This is human nature, right? It's human nature to want to be good at something, and if you're not good at it, to just give up. But we have to learn how to push past that. You're not going to know everything about programming right away. You're not going to get it all right away. And that's okay. Being bad at something is the first step to being good at something. You just got to keep pushing, and that's why one of the big things about programming is that you also have to keep challenging yourself. So when you're working on your programs, best thing to do, don't ask for help right away. Don't ask for help right away. Try to figure it out. Try to push and figure it out. Try to push yourself as hard as you can to figure out the problem. Because if you can figure it out now, or if you can get a little closer to figuring it out each time, you're going to get better at the skills that you need to figure out the next problem. If you just give up right away and you ask for help and you ask me to kind of fix it for you every single time, like, I'll help you. It's what I'm here for. I'm the instructor. I'm the teacher. But then I helped you fix it instead of you actually, learning how to code it. Now, this desire to know, or on the other hand, maybe the uncomfortability with not knowing, can kind of lead to an existential crisis. And I saw this comic, and I thought this comic was really, really funny. Because I've had this exact issue before. Right, in the Java class that I teach. So some of you are in the programming and web development degree. At some point you will take a Java class. In this Java class, I show, when I teach it, I show the class a screenshot of a directory of mine where I was trying to export a game that I had been working on. I had developed a game, and I was trying to export it. And there were probably about 7 or 8 versions of that export in this folder. And with each version, you could see the name of the file change, coinciding with my declining mental health as I struggled to get this game to export and render correctly. I was having the sort of situation, at least in the first 3/4 of this comic here, our friend's having here. Just a full-on meltdown, hating the world, because it wouldn't work correctly. And then, like this guy, I found out that the fix was not a big deal. That it wasn't really even a problem with me, that it was a problem with the actual exporting software itself. And as a result, all I had to do was go in and uncheck a little checkbox that had been previously checked. And all of a sudden it exported perfectly. This will happen more times than it won't. So the big thing there is, just not to give up. Try to solve it on your own. Push through. The breakthrough is more rewarding than the struggle is disheartening. So even if we want to give up, even if we want to throw in the towel, even if we want to say, I can't do this, even though the more accurate phrase might be, I'm not entirely sure how to do this yet. Or maybe it is, I know how to do this, I was just careless and made a typo, and I just need to find and fix it. We want to try to figure it out. And I want to encourage you all to try to figure it out yourselves first before asking me questions. Now, if all else fails, ask me questions. Ask someone for help. Right? Even people that have been programming forever need help sometimes. Right? That's the whole way that programming jobs are built. Right? You have junior developers and you have senior developers. And then, from the senior developer, you might become a junior engineer. or a junior product manager, and then there's a senior engineer and a senior product manager. And all of these people kind of help out the other people, and they figure it out if there's an issue, because you're just growing. As you're writing more code and as you're doing more things, you're growing and you're learning more. So you make an effort, you ask questions, you see how it's solved, you accommodate that knowledge to your knowledge base, so you understand, okay, this is how this works, so now I know how to do that. So if I see a problem similar to this again, then I have this touchstone to hearken back to say, oh, okay, yeah, so I did that back there, I did that this way. And so now I know that, this similar problem, I can do something similar with it. Maybe just change up a couple of parameters. Getting comfortable with asking for help when you absolutely need it is a valuable skill, and it's one that a lot of people struggle with. If you struggle with asking for help when you need it, and as a result, you usually just kind of let things go. You suffer in silence. You don't turn things in. Right? You're not alone. You're not the only person that struggles with these things. But you don't have to. Right? You don't have to struggle with these things like that. You can make your life easy on yourself if you ask for help when you need it. Now, there is a difference between needing and wanting help. Right? Just on the basis of not knowing before we try anything, we might want help. But if you just get help just as soon as you want help all the time, then you don't really, learn anything. Right? At least try it, and then if you discover that you need help through, extended times of trying, ask for help. That's what it's there for. Let's talk about algorithms. So when we think about algorithms, an algorithm in general is like a big, serious topic. Like when we think about algorithms, we think about, maybe what we've heard about in the news or what we've heard about in movies, right? We think about these big, long, complex problems. We might hear about something like the YouTube algorithm, which, makes suggestions as to what would be other videos for you to watch, or, gives your video a value that, ranks it higher or lower based on what it's doing. But all an algorithm is just the steps that it takes to solve a problem. Nothing more, nothing less. Some problems are really easy to solve, and some problems are really complicated to solve. And so the algorithm that we're going to use is going to vary, determined on the complexity of the problem. For example, if we're just trying to figure out whether a number that's been entered into a piece of software is even or odd, that's an easy problem to solve. All right, we just take that number, we compare it to its modulo, the modulus of the result of the modulo problem between that and 2. If it's greater than 0, it's odd. If it's 0, it's even. We'll talk about that next time. We'll get more into what all that means. But when we think about the YouTube algorithm, for example, like for many of you who've probably heard about that, right? That's the problem there is, well, how are we going to rank our videos? How are we going to make sure which videos get seen and by whom? Right, so you have to understand certain things with that. Like, first of all we're really doing here is we're getting a score. We're checking certain things about a video, and we're assigning that video a score based on the presence or lack thereof, or the extent to which something is present. right? So we might see a video that's an hour long, and it might get some points for the length that it is to begin with. Then after it's had some organic reach, we might be able to do some calculations and see like, okay, well, how many people that are watching this video, what's their watch time? Are they watching until the end? Are they watching the first few minutes and stopping? The more watch time that gets put into the video and the more a single person is watching, the higher value it's going to assign to a score. And so at the end of the day, we're just checking a lot of these different little matrix about a video, right? We're just looking at a lot of different attributes and we're just assigning it a score based on whether these things are present or how well these things are done. And if that score is a good score, we recommend it to more people. If it's a bad score, then we don't recommend it to as many people. Maybe we even go so far as kind of hiding it from suggestions. And when we're doing that pre-writing that I talked about earlier, what we're basically writing down there is, well, we're writing down this algorithm, these steps that we need to take to solve this problem that we need to solve. And there are 3 important factors to consider when designing an algorithm. 1 is that the algorithm must be well defined. 2 is that the algorithm must be clearly given. And 3 is that the algorithm must solve the problem. So the first thing is that the algorithm must be well defined. It has to be specific. We need to know the core, how specific our problem is, so that we can define an algorithm that will meet that problem. Since our computer is dumb, and we're giving our algorithm to a computer, we need to define this algorithm in such a way that there is no ambiguity in terms of the steps that we need to follow. That's kind of the point of your discussion board assignment for this module. Is that you have these seemingly mundane, everyday tasks, but you have to create an algorithm in which to do them. And one of the big challenges here becomes the fact that you have to clearly define the algorithm. So you have to go through each of these everyday mundane tasks that we might not even think about when we do them, right? They might just come second nature and we just do them. These tasks that we have every single day, we actually have to think about how we would explain how to do these tasks to someone who had little to no idea of what we were talking about. Right, and some of these algorithms that we have in the discussion board here are really fun to do in a seated setting, especially one where you have a little more time to play with it and time to kind of prepare and work with it. Right, I wasn't able to do that in my seated section of the class this year because it's a 8-week seated section, so we were running pretty quickly. Didn't really have the time to sit with it and unpack it. But it's really fun, and it might be a good task to maybe do with a parent or a friend, or just to kind of do on your own, maybe after you've written down some instructions, is the peanut butter and jelly sandwich algorithm. And to take peanut butter, to take jelly, and to take a loaf of bread, and only following your instructions, and following your instructions specifically, as a computer might, try to make a peanut butter and jelly sandwich. Did you forget to open the bag? Did you forget to take the lid off of a jar? Did you forget to get a utensil to spread the peanut butter or jelly onto the bread with? When you stick it together, how did that work? So on and so forth, right? Which is pretty interesting when we think about something like that. Another interesting thing to think about when we're dealing with one of these algorithms is the fact that somebody actually did write an algorithm for how to make a peanut butter and jelly sandwich. Computers make peanut butter and jelly sandwiches. There is a Smucker's Uncrustables factory running right now, where in order for those machines to make that sandwich, they had to have an algorithm to make a peanut butter and jelly sandwich. How much peanut butter, how much jelly, how do I spread it out, where do I cut, so on and so forth. So you might even think that, an algorithm for peanut butter and jelly, that sounds silly, but it's real. It's real. It's a real problem. So you want to make sure that your algorithm is clear in every single step, that you're not skipping anything, that you're making sure that everything in there is there so that when you get to the end, your end result is also clear. The next one is that your algorithm must be clearly given. So you want to make sure that nothing's been skipped, overlooked, or left out. And really, when we talk about both of these, well-defined and clearly given, right, we can kind of talk about them in like the same sort of terms. Right? Well-defined means that we have an understanding of our problem, basically, so that when we clearly give our algorithm, it is not skipping a step. And then finally, our algorithm must solve the problem. Right? If you went to make a peanut butter and jelly sandwich and you ended up, doing your taxes, there's a bigger issue. There's a bigger issue there. Let me see where I am here. Let's do a couple of quick examples in Scratch to kind of show you a few different things. And so even after this module, right, the lab for this module doesn't use Scratch, but it uses something that looks very similar. And when you log into Scratch for the first time, you'll see something like this. Even after this module, you might want to revisit Scratch and work through it, especially, some of you might be familiar with this, to help you sort of understand a problem that we're going to write in other forms of code as we progress. But we can click Create up here at the top, and we can create something relatively simple. Now, the first thing that we need is an event. So we see events here on the left-hand side. 4 down from the top, our yellow circle, that's events. And an event in programming is just something that happens. Right? So typically we say, one of the languages that we consider to be an event-driven language is JavaScript. JavaScript is an event-driven language. And so that means that it's waiting for something to happen. It's waiting for something to be clicked, a button to be pressed, a certain amount of time to pass, and then it makes something else happen. So here we can see some of the examples of our events. For example, we have here when the flag is clicked, which is this flag here. When space is pressed, which is the space key on your keyboard, we can take that and make it any keyboard character that we want to make it. When the sprite is clicked, so when we click that guy, or what have you. So I'm going to throw in this when space key is pressed. In order to do that, I just take the puzzle piece and drag it over here to the middle. And now it's a part of my puzzle. And so from here, one of the things that I might want to do is I might want to create a variable. Right? We can talk about variables for a minute here. when we're talking about a variable, and we'll talk about variables more when we get later on, a variable is just like a box or a jar or a little bag, right? It's just a container that we use to temporarily store a value. And so when we create this variable, we're giving that variable a name. So whenever we refer to that variable by name later on, we are not only, we don't have to refer to the value that's in that variable. We can just refer to the variable by name. So in this example here, we can take and we can go down here, it's the second from the bottom, and create a variable. And we see we have a little box here that says make a variable. I can click that. I can give it a new name. Maybe we'll call it number. Right? We can make a variable with whatever name that we want to give it. When we get to Python next week, we'll talk more about some limitations on the names of variables. But I can click OK here. And so now I have a variable value that I can use here. So I can take and set some variable value. Right? In this case, I want it to be the variable container that I make here. So I can drop that down and select number and give it some value, like let's say 10. Right? And now you see we have a number. When we press, we have number 0 up here. When we press the space key, that changes to number 10. Right? And if we were to reset our program, we could reset it back to 0. So let's write another little, we can make another little block that does that. So if we go back to our events, we can grab this when space key is pressed again, but this time we can just change it to any other character. Maybe we can make it be A, so when A key is pressed, when the A key is pressed, we can take our same variable here, and we can set my variable, in this case my variable is number, to 0. So now if I press space, the value that is in my container called number is 10. And we see that no matter how many times I press space, it just stays 10. But if I hit A on my keyboard, it resets it back to 0. Now I can take this a step further, right, and introduce a calculation into this. So if I look in the green here, these are my operators, and this is where I do basic calculations. So maybe what I want to do is say, okay, well, I don't just want to make it 10 when I press spacebar. I want to make it add 10 to whatever the current value is in the number variable container. So I can take this, I can put it inside of there where that 10 is now. So now it's blank plus blank. In my variables, I have my number here that I could add in. So I could put my number variable into that first slot. And into the second slot here, I can just put a number like 10. So now, instead of just setting it to one number, every time I press spacebar, we'll zoom in here to number on our screen up here. So you can watch it. Every time I press spacebar, it's adding 10 to that value. And if I want to reset it, A to set it back to 0. And so that's what's happening, right? We have an event and we have an event. We actually have two events here, and we have variables. And our variable is waiting for our event to happen. And so everything else, our loops and our conditionals, we have covered in the module. So I encourage you all to watch those videos to get more information on that and how that works here. We've about hit our hour here, so I'm going to go ahead and stop for today instead of getting deeper into that, because this is just a good stopping point. We'll hang out in the chat for just a couple minutes, just in case anybody here watching with me live has any questions. If you're watching the recording and you have questions, feel free to send me an email. But that's all that I have for you for now. Thank you for watching, and we'll see you next time.